Hello everyone, this is Fuge Zhou, recording a video, a demo for creating a end-to-end solution for telecom churn case studies. Telecom churn case study was a popular uh, case study in Kaggle. So let's just review the data, right? So telecom churn, we are grabbing the data from this Kaggle case study, right? You can see this is very popular. Predicting the behavior of a retained customer, you can analyze all relevant customer and develop focused customer retention programs. You have customer who left with the last month's services with each other has signed up. They have their phones, multiple lines, internet, online security, and you have the customer account information, how long they have been a customer, and demographics or info about customer, right? Their gender, age, right? So this is a data set that we are using for this demo. There are 7,000 unique customers, so we're going to predict. So let's create a project in our platform. So right now we can just go to projects. We can create a new project, right? The project name is telecom churn AskAI, right? Using our most advanced AskAI for doing this task. So we can select the nice pictures. Let's just say if it's churn, let's just do a churn. And just leave everything as default, right? Just say create. So now after creating this project, we're in this canvas view. So we can add a new data set. We can either add from GCP bucket or local file. For right now, let's just connect to our GCP bucket, right? Just show you how easy it is to pull data from existing cloud service. So we are connecting to the Google Cloud Storage in our server. So we can just click on the demos and telecom. And let's just go find telecom churn. Let's just say churn telecom. Let's just import the data, right? That's very easy to do. So this is the train data. So let's just say click next. So this will talk to the this CSV file in the Google Cloud Storage, and let's just name the dataset as train. This is how we build the model, right? You can see it is it's very fast, right? It's done, and we click done here. So I believe that will be a data set, right? This is a train data set. Once we click that, we will have these can view the data, right? Give us an overview of the data, so including the schema set. You have a customer ID, gender. Are you a senior citizen or not? Do you have a partner? How many dependents do you have? How many years you have to stay with this service, right? And phone service. Do you have multiple lines? Do you have internet service, online security? So these are the features we try to dependent variables we are trying to independent variable we are trying to integrate, right? This is feature engineering, and our target variable or is churn, whether yes or no, whether this customer stay with the company or not, right? So we have this data. So what we're gonna do with this data? So right now we can do some some simple prompt, right? We can say this is AI assisted, so we can pull the pull the chatbot, which is our AskAI, and you can chat with your data, right? Let's just say generate data summary table on column name no values, unique values, first and last row of this table. So we're just gonna generate a table that summarizes what this data is, right? So let's just say go, and see how that goes, right? This will help us to generate an overview of the data, just generate a data summary, right? So you can see, let's just put this larger. So it will generate a data table. So you have 21 columns, right? And you have a total 7,043 records. You say customer ID seems like it's a unique ID column. And you have gender, which is female, male, and senior citizen. That's a binary features. And you have partners. You have the independence, tenure, right? So numerical features. So these are the data summaries, right? So let's do some. We notice that in this data you have total charges as a float, and we're not going to drop the customer ID for machine learning. So our goal is to build a model for machine learning, right? And we're going to fill the null for each column for with median value of each column. So let's just type in here, based on the observation we have for this data. So we are going to convert the total charges from columns from string to float. Notice, let's just go back, right? Let's go back to the data. Let me show you why. The sigma said total charges is actually a float. I think that's correct. So we probably don't need that. But we are going to mention that here anyway, because that was let's just say drop column customer ID, right? Drop the customer ID column. We believe that's unique ID column. That's we are not gonna use that for machine learning. And if we need to fill null values for each column with median and values in each column. So let's just do this and see what happened. So, and we're gonna use the original train data, use our prompt engineering on the data using our AskAI tool, and if we generate this like clean version, you can see, compare the data, the original data and this data. You notice that customer ID is gone, right? We drop the column here, and we leave only these good columns for machine learning. So our target is churn, and the rest of these like 19 columns are the features. And at this moment, I think the data is ready to go into our rapid model. So so before we're doing that, we can just say for this step, right? For this step, we're gonna convert this into a recipe, and we're gonna name this as clean train underscore with clean. So which means this is a clean, which means after this process, this data will be a clean version on the train data. So it will be ready for going into the machine learning. So we can save this, and we can run this, right? We can run this, and let's see what happens. So let's go back to the canvas view. You can see there's a train with clean. You can see under this train with clean, the first column is gone, which is customer ID. We don't want to use that for machine learning. And we fill all the null values, and we converted all the data is in the right format, right? The data format, the data type is correct. So let's move on into add a new recipe, rapid model, right? We're gonna do machine learning model based on this train with clean data set, and we're gonna do binary classification. And our target column is churn, because we know churn is a yes or no. We're trying to predict yes and no, okay? Just with zero coding, you can just save this and simply run. So it will take a while, but under the hood, it will have 4 steps. One is it will help you further clean and processing the data, and it will have add all the feature engineering, and it will have model training and selections, performing the best model with best accuracy, and save that as the artifacts, right? The model. We're gonna use the model for prediction, and then we're gonna see the accuracy of the model. It will give you all these. For binary classification, it will give you the precision recall and F1 score on based on the cross-validation results, right? So under the hood, it will run for a while. So and eventually it will generate the model. So let me pause here. So it is running like 2 minutes. I just count. So after 2 minutes, you can see we have this process has been finished, and the output it generated has, of course, first of all, the predicted results, right? The machine learning model is going to predict the yes and no for churn. You can compare the actual results versus predicted results, and with the probability of no and probability of yes. I think the yes and no is where probability is over a threshold. It will decide whether it is yes and no for the churn. And that is the first output. The second output is basically the audit, right? Audit report. What columns we add, what columns we dropped. So among all this feature engineering, so each column has got its special treatment, right? Well, I think in general speaking, it will convert this categorical column to a numerical column using the one-hot encoding. It will drop highly correlated columns through the feature selections, and it will drop the ID-like columns, drop constant columns, and drop the no information columns, right? It's gonna do lots of feature engineering and feature selection and feature cleaning under the hood. So that is and it will be auditing here just for full transparency. And the third output is the charts, right? The machine learning charts. You can see the feature importance, confusion matrix will help you not only see how good the model is, and also what is the important key drivers. And you also have advanced model insights such as the correlation matrix, Shipley plot for AI explain, and you have learning curve, and you have the local AI explain. So you will refer to these as which one is the largest driver, right? For example, the contracts month to month seems like a very big drivers, and you also have total charges. Seems like the higher the charges, the less likelihood to become a churn customer. And you have the positive rates and threshold against precision and recall, and false positive rate. These are the key metrics for machine learning performance. And you also have the model summary. What kind of model we tried? We have gradient boosting tree and XGBoost under the hood, and these are their performance, right? Their feature importance. So this is the third output. The fourth output is the model itself, right? The model itself is actually pretty cool. We saved the best model in here with all these output and with all the model artifacts of the data as this will become a prediction service for later. And we also have these like images and visuals and all the by metadata associated with this model performance and output as an artifact. So that would be our the model output itself. After this, right now we have a new data set, right? So we can go to our prediction job. What the prediction job was doing is we add the prediction from the model, right? Now we can upload a new file, right? We can say, how about we're interested in the new record, which is one record. Think about this is like when you put this into production, this is either a API service or a stream online streaming, or like a batch processing. You have a bunch of new records, and you are gonna predict on the new, apply the model, existing model, and predict on the future. And right now you just hit generate prediction. So under the hood, it will load the entire pipeline, just like the training process did, right? But we're gonna have exactly the same process for feature data cleaning, feature engineering, model prediction, and we're gonna output this new record, the prediction results of this new record. This is where you deploy the model and put into production mode. And later, where you can convert this to API, REST API service, or a prediction endpoint, or batch service, right? Or a cron job. You can run this in a real-time mode, or REST API mode, or in a batch mode, depending on your business needs. So let's go back and see the prediction, right, was created and running using this model, and it was successful. If you click into the model, it will tell you the prediction results, right? The prediction results is no, with probability of no being 96%. I think that's a true positive case, right? The model will, the sample we selected is a no case. So that is concludes to the prediction service. Last not but least, once you have all these project pipeline created, you can also create a data app, a fancy data app without coding. So you can say this is the telecom churn app, and we're gonna create this clean based on this clean data set, and we're gonna choose just a fancy image to represent this data app. And what's under the hood, it will use our default templates to create a nice and customizable data app. But this data app, you can also work with our data scientists to optimizing, customizing this dashboard based on your business needs. So that will be very easy to do, either by yourself, if you know the little bit Python code under that, or by working with us. So it is running now, and we just say click into that. It will show you a nice dashboard showing you the data app on all these related features and output from the model, right? You can say this is the feature importance, and you have the explanation, right? These are all generated by using our proprietary AI algorithm. So you can say the explanation is that the contract month-to-month features, this is automatically generated, right? The contract month-to-month has been the highest importance score, meaning it is the most influential factors, and others such as total charges and online security, they are also important key factors for these particular problems. And you have the model performance showing you a confusion matrix. What they mean is that it will have all these positive, true positive, false negative, and true positive explained in plain English here for business users. And you can also do what if analysis here. You can predict what if outcome, right? You can switch the parameters and do some sensitivity analysis and what if analysis for your performance for predictions. And you have prediction. This is similar to the prediction service we just used, right? In here you can browse file and do prediction in this tab. And you can also ask AI in here. You can chat with your data, and you can also add additional charts by customizing that. So that will conclude to a simple demo on how RapidCanvas how the business user can use RapidCanvas to end-to-end machine learning task without any coding. So it's super friendly, user friendly, and super easy to do. Thank you.